Gracias, Ricardo. A continuación va a intervenir Roberto Hernández.
Stretch of road. In cartography, he is the head of the Department of Cartography in CSG. It's an organism, a body which depends on the regional government, and he specifically belongs to. Oh, don't worry, Chup. With GVT. Don't worry, we're not really worried. I don't think anybody's worried about these names. Right, can I start? Okay. Right, sorry. Right, let's go to the first here. Right. Good morning to everybody. I'm José Roberto Hernández, and I've come here a little bit. I belong to the Center for Road Management, Cartography, which belongs to the. Well, he said it belongs exactly to the regional government in charge of road works. So we're going to look at the new 2.3 version, the new tools. There's going to have dynamic segmentation, which my colleague spoke a little bit about before. And also what I'm going to do first of all is say who we are, what we do, and why you need it. Why we need these type of tools. Right, to begin, although there's many more things. The SIG EV. We need to get cars to circulate correctly on the roads without any danger. How do we do this? Well, as you can see, we do this. We have a traffic management center, which you can see here. As we see on the news, when the road managers come out, which uses information in two ways, twofold. We have devices which are installed on the roads, cameras, for example, or meteorological stations, weather stations, or by telephone. We're connected permanently to 102, the emergency telephone number, 999. And once we detect an incident which is related to the roads, they discriminate between our roads in the regional government, they ring us, and the operators who are in the control room then will let the conservation company, the corresponding conservation company, know what is happening, so that they will then look after the incident, whether it's an accident or a dead dog, anything which could happen and which could impede the normal circulation of cars. Also, we could detect an incident through a camera or a phone call, like a traffic jam, for example, and from the control room we can also then control the variable message screens which you see here, the panels which you see here, which will tell you that roadworks going on or that there is a traffic jam, let's say in 6 kilometers. This is also managed by the control room, the control center. Apart from this, we have different departments. We have the control center, looks after management of incidents. And here we've got a load which is overturned for a lorry. And it's also the viability. It's also very important. We can control the fleets, for example, of the snow plows, so that no village would be cut off, or at least cut off for a minimum amount of time possible. So do these snow plows know the way to go? They have tablets, yes, so they can find out. Maybe suddenly we've had a 1 meter snowfall, so we need to clean these. We've got a maintenance department also, which looks after installation and maintenance of the devices that we've seen on the roads, cameras, etc. ETDs, any types of the weather stations or the contamination stations, etc. pollution. We've got also the photos. This measures the amount of traffic which goes along a road. This just measures the number of traffic which we have, for example, in a certain period of time, where it's set on different stretches of roads depending on the characters. We measure the traffic once a year, twice a year, or depending on the day. And at the end of the year, we draw up a report with the intensity traffic per day, both heavy vehicles and normal vehicles, which will allow us to manage road management, whether we need to extend the roads, etc., or look after traffic, particularly in a specific zone. And we also generate maps which can be used. We also have an engineering department which looks after all the data from all the data which is collected. They make models of them. The new ways of calculating the SMDs, they calibrate the equipment, etc. They do all these sort of things. This is done by the engineering department, and then the IT department, looks after all the software, hardware of the center, and everything related to IT, obviously, they repair and look after. Then us, we have the mapping cartography department. So what do? We would do technical drawing works, and we also need a technical drawer to be able to do these kind of things. We also have maintenance of official catalogue of roads, official roads, because we look after and define what this road is, where it begins, where does it end, and who does it belong to. There are 4 big administrations who have competencies in roads. That's the ministry, the regional, the local areas, and finally to the town halls. We need to know where it starts, where it ends, and to which administration, which administrative unit it belongs to. Obviously, we need to be able to send the information to the correct company, obviously, or to the correct administration. From here, the most important information will be SIGs and PKs, the points of kilometre points. We need to take a look at where the companies are, the routes for the snow ploughs, for tunnels, flyovers, anything that could be mapped. We would be in charge of it. And then from this cartography, we also have derived products, plans, or specific studies. Anybody who comes and asks us for something specific, which we can do, we will do it. And if not, and we would then use the GIS tools. Here we have what we mentioned, the most important information, which are the road links and the kilometric points, because each axis has its own particular dates, each link, and each PK has its own alphanumeric data. And this will then be provided to the administration. Blue is administration, is a ministry. Green is the local administration. And the mauve colour is the town halls, the councils. This will be our base. How do we update this? 3 basic methods. Well, the usual methods. Visualizing on a photo. When we detect changes in the roads, and there are lots and lots, believe me, even though you may not think there are. What we do is, and the road isn't, and the auto-photograph isn't correct, we get in touch with the administration who are in charge of the work, and we ask for an AutoCAD. We say, perhaps they will not listen to us, but then we go ourselves with our own GPS, and we take a record of it. Here we've got an example of the different products which we have. Here we use basic cartography of PKs to develop a technical map of maps by province. We have the different build-ups, the number of cars, the number of heavy vehicles in certain areas. Here we have a cartography of tourism, for tourism in this case. Here we have a map we've generated based on meteorological station cartography, where each of them are. And here we have routes for snow ploughs. And here we have the snow plough, who knows that they know where to go, in what order to go, depending on the importance of the road, in order to clean the snow which has fallen. It's not all cartography, we also do alphanumeric work. If we're asked for registry on about the length of each road exactly, or we group things by types, how many roads there are which have got great capacity, for example, in Alicante, because it's different to look after a road with 2 carriageways than one that only has 1, or a road which is a 2-way road or a single-way road. And part of our work is to manage all of this. We don't do it directly. We are given this database information with the incidents which occur in the roads, and we upload it to the database, and we have an app which allows us to exploit this data and to generate reports which you are looking at here. Right, we also have a WMS service. We can connect to any user, can connect at any time, but also it's integrated within the Terrasit portal for ICV, where the axes are loaded and the kilometric points and anything related to traffic within the past 3 years. This is used perhaps maybe once a month, but it depends on the changes that occur, of course. But the cosmetic changes, obviously, we tend to update a bit later. What's our problem? There's no coordinates. Nobody uses them. We're talking about kilometric point and road. So when the Guardia Civil, they always mention the road and the kilometric point. There are no coordinates. Everything lineal is used. They only use lineal explanations. And this means that we need to go to a dynamic segmentation. What is exactly dynamic segmentation? I'll try to explain if I can do. It's referencing any element which could be on the road using certain measurements during a lineal measurement. I know that might sound a little bit, it's hard to understand. I didn't really understand it myself at first, to be honest. If we have a road, and between PK3 and PK4 kilometre, firstly there should be 1,000 metres, as my colleague said, but there never is. There may be 1,000, but in between these two points, between these two kilometric points, there's a village, and so there's a variation in the road where it diverts off, and then it rejoins the road later on to go into the centre of the village. Then they don't take a kilometry of all the road. Obviously, if we have a road is straight and then we have a diversion of the road, then obviously we made the road longer. So what we need is a way of saying this lineal expression in each point of its way, what value each kilometric point has, which doesn't correspond with the length. I mean, for more than 1,000 metres, it can't be, or it shouldn't be more than 1,000 metres. But we're going to take a look a bit later about how we do this, and we could say, without making a mistake, the road with the dynamic apps we have, we can extract this from our road catalogue. We can take out any element which it refers to PKs, proportions, certain points where there are accidents, for example, or road or holes in the road. This data we can extract if we want, and we can do, well, additional studies, whatever we want. We can work with this data as though it was an independent layer. And our mainly to work in the dynamic segmentation is the route. We're going to explain now the route in dynamic segmentation. Here we have a route. It's an element, linear element. It's got different attributes, but they've been identified with a specific field. In our case, it's always the name of the road. For us, the route is the name of a road from its beginning to the end. It's identified by its name. GV300, for example, that's a route. So we have defined route for each of our roads. What about the geometry of the routes with the normal linear element of an element? A geometry of lines, a linear geometry is defined as different x, y. We have 3 coordinates. We've got an x, a y, and an m, the coordinate m. We can be whatever we want. The value in our case is going to the value of each kilometric point on the line. This is going to, in the end, enable us to locate on this line any element that we want. These values are saved for each part of the line. So we go from 2 coordinates to 3 coordinates, which is not 3D, but it's a third coordinate. It's a linear reference throughout the road. Then we have calibration, which is very important. Basically consists of a series of points along the axis where we know the real coordination value of the m coordinates. These PKs will allow us to interpolate from the line to between 2 points, or we can extrapolate it where we don't have 2 points. When you get to the end of the road and you're in the land end segment, there's no PK, then you get to the end of the line with the length. Then we've got the different events, table of events, which we all know. It's a table where we have various fields and where each can identify part of the route. One has got to be the route and one has got to be PK. If we have a field of the PK, they've got to be specific events. And if we have PK, initial PK at the end, then we're going to talk about lineal. Lineals could be limits, stretches of roads where there are speed limits or areas where there are road accidents. Here we have a route, or 8. coordinate 62, and we see the tables, one of points with the route and the kilometre, and the other of lines with the route and the initial kilometre and the final kilometre. And with the lines, we take and we extrapolate the corresponding points on the line. Right, where do we come from? Right, we're an application, a road app for management developed, and we also worked in dynamic segmentation, but the problem was that we're working with gvSIG 1.9. This dynamic segmentation only worked for post-GIS, and this is a bit problematic because it's quite unstable. You need a great amount of data. It's got a very, very developed alphanumeric part, but it's very difficult to use for cartography. Very, very hard, difficult because of the speed, because of how difficult it is to do. A lot of complications involved. So we spoke to the SVG Association. We said, can you make some tools for us to do dynamic segmentation for shape? And they said yes, and they've done it. They've done the two things. So in the revision 2.3, we will have dynamic segmentation for shape. It's great because we're able to update the tools to the new gvSIG, which means then we'll have access to the cartography which will be developed in gvSIG. Better, we improved the calibration because we had to do the calibration of the routes outside the application because we didn't have a calibration process within the app, so we had to do it outside. Then we had to upload it to PostGIS, and then we had to, if the association wanted to in the future, if they want to update all the apps related to accidents, it would be extremely interesting. From 2.3, my life has become quite better thanks to the version 2.3. I find things much easier to work. Now I'm going to show you some videos so you can see everything that I've explained to you a bit from a difficult way. You can take a look at the tools which have been created. Here we have. First video will explain how to create routes with the tools we've got, as you see here. So the links or the axes which are loaded in Castellano, and we've got some kilometric points, the PKs. So it's as simple as, here are the attributes of the axes which tell us the name of the road, which is going to be identified. It'll identify the route, the name of the road. Then we've got the tools are up here at the top. We say create route. We're asked about the origin. We're going to create a route. Which field is going to identify the route? The output file for the new themes. The origin of the measurements. Sorry if I don't do this. Oh, only 1 minute left. Right, I better go. The measurement, which could be the length of each segment, or if we have a PK in two fields, initial, end for each segment, where we have to say the field from and to. Where the kilometric points begin to increase, and we have to scale the elements. We say yes, and so we've got routes where we have merged the route, and each route only corresponds to a particular road. Right, I'm sorry, I'm going a bit quickly here. I want to show you the video. This is a very important route calibration. We have the axes where we have the PK field, the name field. We select the road we want to calibrate. We say, please calibrate it. We get the origin of the route. What is the identifier? The route identifier. The origin of points which need calibrating. Also, it's the name of the road and the PK, the output file, and also we need to interpolate. We need to extrapolate the points which don't have a PK initial and a PK end. We ignore spatial gaps when we have a gap from one point and then it jumps. What we can say is we ignore it, or that it should take it into account. We're telling it to calibrate it for us now. And okay, it should have done it. Right, so now we can start to edit the issue. And if we can edit, you can see this line, which with the PK initial, the end, and its M value. And we can invert and change the M coordinate. Let's take a look at the next slide, which is very simple. We have a route which is calibrated, and we can now put a layer graph how the M coordinate develops during the segment. We can put a tag for every 500 meters, for example, and it'll set it for us here or here. I'm going to get rid of it. There's nothing else here. And then to finish this now, we have what we've been working on, the possibility of, sorry, okay, the occasional events we can calibrate, and we have a linear event and a PK. We have initial PK, we have final PK. Yeah, sorry. I know I know I'm going a bit too. Sorry. Right, so we tell it. We tell it our root layers. We want to extract the PK initial, PK final. I don't know why this keeps happening. No, right. Sorry. And if we go to the end, directly to the end here, we can see that the segments which have been taken out, the linear segments, and the linear segments are in red also. It's a tool which is extremely useful, especially for people who work on roads, and you can work with their GIS directly. And it's going to be extremely useful, especially for me anyway. And I think that is the end. If I find it. Yeah. Any questions? No, thank you.